Solving systems by elimination. In class, we worked with your foldable. We've already been over. Given a graph, I can find the point that they intersect. Given a situation where one variable is solved for, I've got a sub, and I can sub it in and get my solution. Again, I'm looking for the point of intersection. So under the elimination tab, we filled this in class. If they're both in standard form, these two are, you've got x's and y's on the same side, your constants on the other, then I'm going to use the elimination method. And elimination means to eliminate, to get rid of. So what I'm going to do is get rid of a variable. So if you look in this negative 4 plus negative 4x plus 4x eliminates, it's 0. Negative 2 plus 8 would be 6y. And when I add negative 12 plus negative 24, negative 36. So I divided both sides by 6. I ended up with this guy. So I plugged him in for y. Then they went back and they took the second equation, 4x plus 8. But notice where there was a y, we plugged in what we got, equals negative 24. When you multiply 8 times negative 6, that's where we got negative 48. So to cancel it, we added 48 to both sides. So then we divided both sides by 4, and we got x to be 6. So I'm going to do some more practice because many of you saw that in class. You can get that filled in from a neighbor. So we're going to do this first scenario here where I have x plus y equals negative 1. Sorry, equals positive 1. And negative x plus y equals 5. Now, if you notice, both of those scenarios are in standard form. And I don't have a substitute ready to go, so what I'm going to do instead is I'm going to try the elimination method, because when I add x plus negative x, it eliminates. Y plus y, there's a 1 in front of that y, and there's a 1 in front of this y. So 1 plus 1 is 2y. 5 plus 1 is 6. So I'm going to divide by 2, and I'm going to see that y is 3. Remember, I'm looking for the point of intersection, so y is 3. Now, I need to still know x. It's missing. So I can use the first equation or I can use the second equation. Doesn't matter. I'm going to choose to use the first one because there's not a negative, so I'm going to say x plus y equals 1. Now, the reason I put a parenthesis is because y is 3. So I really equals 1. So we're going to subtract 3. So make sure you use your calculator, please. So that's what I get here. In order to make sure I am correct, I'm going to double check. I have x, and I know x is negative 2. Plus y. Y is 3. Enter. You see how it equals what I have on my paper. So that's not sufficient. I have to check the other equation too. Now this is important. There is a negative, so I type a negative. And then I see x. X happens to be a negative 2. The negative in the problem, the negative for x, they both go in. It says plus, and y is 3. And notice I get 5. So I have done this problem correctly because this point worked in both equations. That is the point they share in common. The point on the graph where they intersect. So let's work another one. 2x plus y equals negative 1. 3x minus y equals negative 9. Now, again, if I go ahead and add these, but this is different. See here, my x's canceled one another. Now y minus y is going to eliminate. So I got 5x equals negative 1 plus negative 9 equals negative 10. So I'm going to divide by 5. Again, I'm putting an ordered pair down. X is negative 2. I have to go find the y value. I can use equation 1 or 2. It doesn't matter. I'm going to pick the 1. So that's 2x Oops, I don't want x. I know what x is, so I'm going to plug it in. So 2 times x plus y equals negative 1. And 2 times negative 2 would be negative 4. Now my job is to get this y alone, so I'm going to add 4. So I get y equals negative 1 plus 4 would be 3. This is the reverse of what we had just a minute ago. I had negative, no, it's the same thing. Look at that. Let's make sure we're right. So, turn on the calculator. I see 2. X is a negative 2, so plug it in. It says, oops, sorry. It says plus, and then I'm going to plug in y. It does equal negative 1. So I've got to do this version, 3 parenthesis, negative 2 for x. Minus is in the problem. Plug in y. Y is 3. And it is negative 9. So this is the point of intersection for these two lines as well. Interesting. Alright, so here's where it steps up. And it gets a little bit tougher. It's very simple as long as you've already got something ready to cancel. But given this problem, when I add 2x plus x, that's 3x. Didn't eliminate. Negative y plus 3y, that's going to be 2y, so those didn't eliminate. So I have to force these coefficients, the number before the variable, to be the same. These 1 and negative 1. 1 and negative 1. In your foldable, it was negative 4 and positive 4. Same coefficients, opposite signs. So I'm going to have to force that to happen. When I look here, I see 2 and 1. They could be the same. I see negative 1 and I see positive 3. I'm going to try to change this. We are only allowed to change by multiplication. So in order to make a negative 1 become 3, I would multiply it by 3. Let me prove it to you. 3 times 2x, that's 6x. 3 times negative y, negative 3y. You see a negative 3 and a positive 3 will cancel one another out. Same coefficient, opposite signs. But you also have to do 3 times 8. Do not leave it. This number must multiply by all of them. The second equation I don't need to change, so write it down. And now we're ready to add. 6x plus 1x is 7x. Eliminate. Negative 3 plus 3 is nothing. 24 plus 4 would be 28. So I'm going to divide by 7, so I know x is 4. Remember, I'm looking for the point of intersection, and I know x. When you do this, you can pick one of the originals. Do not use a changed equation. So we're going to go with this one. So where I see x plus 3y equals 4. I'm going to plug my 4 in for x, because x is 4. And now I need to get rid of that 4, so I'm going to subtract it. So 3y equals 0. I divide by 3, so y is 0. I'm ready to check it, so I go to the original problem, and my ordered pair is 4, 0. So 2, x was 4, minus, and y is 0. Enter. X is 4. Let me plug it in parentheses. X is 4 plus 3 times y is 0. Enter. They work. That is the point of intersection. So let's try another one of these. Let's try 2x plus 2y equals 4. Negative x plus 2y equals 4. Now if I add, these don't cancel. If I add 2 plus 2 is not 0. 2 plus 2 would be 4. They do not eliminate either. So what I notice is several things could happen. These guys, if they had an opposite sign, would cancel. here if this had a 2, because 2 minus 2 is nothing. So I'm going to go ahead and multiply this by 2. So 2 times negative x, 2 times 2y, and 2 times 4. That equation changed. The first equation didn't change, so let's leave it alone. And now I can add, and I'm always adding. 2 minus 2, 2 plus negative 2, gone. 2 plus 4, 4 plus 8, and now I'm ready to divide. So y is 2. Now when you do this, make sure y is 2, not x, y. Alright, I can pick either of the originals. It is totally up to you. I'm going to go with the first one. So I'm going to say 2 and an x plus 2y is 2. Okay, 2 times 2 is 4. I'm going to get rid of this 4. So I get 0. Divide by 2. So x equals nothing. Alright, so now, again, I'm going to go back to the original, and I see 2x plus 2y. It equals 4. Second equation, I see a negative, so I have to type it, and then I'm plugging in x, which is 0. Plus 2 times 2. And it works. So that is how I solve using elimination. I have to make the coefficients the same with a positive and a negative version in order to get them to work.